Measuring temperature with a thermometer is usually a pretty objective measure. It's likely that over time, the measurements will remain consistent and that they will continue to be interpreted by a researcher in the same way. But lots of measurements are more subjective. This is especially true in behavioral research. But even in basic science research, measurements could involve interpreting readings that aren't clear-cut. It's possible that, over time, the way that a researcher makes these interpretations could drift. This is called intra-observer variability, and it's the topic of this module in experimental design. One way to avoid issues of intra-observer variability is to define the measurement procedure as specifically as possible to take out human interpretation. The more objective that you can make a reading, the less chance that a drift in interpretation could lead to variability over time. If we were measuring activity, for instance, and just classified that into 4 groups, say highly active, moderately inactive, and inactive, then it's possible you might make a reading differently at different times. If, however, each activity group had a strict definition, such as how much time was spent in motion and how far one might move in a given period of time, then it would be more likely that you'd make the same classification again and again. Another way to limit intra-observer variability is to group measurements as closely together as possible in time. If, in a short period of time, say a day, you made all of your readings, then it's more likely your reasoning would be consistent. If, however, you made your readings over weeks or months, then it's much more likely that you would do things differently at the end than you had been at the beginning. Since you can rarely do everything in an experiment in a day, one way to control for intra-observer variability is to do repeated measurements. If, at 2 separate time points, you achieve the same measurements on the same inputs, then your confidence and consistency rises. If you find that you're scoring the same outcomes differently at different times, though, then changes need to be made to the measurement process to address that variation. Ideally, the sample that you're measuring more than once should be chosen at random. This practice is known as conducting a repeatability study, and it's an essential part of limiting intra-observer variability. Often it's helpful to plot a repeatability study. Let's take an example. You place your first reading on the x-axis and the second on the y-axis. In an ideal situation, all of your readings would line up on a straight line, extending out from the origin at a slope of 1. Any deviation from the line is intra-observer variability. If the line created by the point slopes away from 1, there's a consistent bias. Just noticing the biases isn't enough, though. You have to correct for the issues. If you come to the conclusion that some readings were wrong, though, you may need to repeat them yourself, or have someone else do it as well. That can bring up another type of variability, though. Inter-observer variability. Because if you're worried that you yourself might take the same measurement differently over time, that's nothing compared to the chance that 2 different people might measure things differently. When it comes to subjective and even some objective measures, different people have got to be taught how to measure similarly. Of course, you could get all the measurements to be done by one person. You're more likely to get precision that way. But that might limit accuracy. Getting multiple people to measure reduces the chance that a bias could come into play. Accuracy might go up at the cost of precision. You could help this by performing the same steps as before. Define measurements clearly. Check measurements against each other and against gold standards. Take a random sample and perform a reproducibility study. You likely can't fully eliminate intra and intra-observer variation completely, but you can take steps to minimize it.